So today I'm going to cover thermodynamics, section 6.1 and 6.2. Okay. So thermodynamics is just a branch of physics concerned with heat and temperature and relationship to energy and work. Or in general, we could just say it's a relationship between different forms of energy. Okay. We need to look at a few things before we actually get into talk about solving thermodynamics problems. We need to cover some things around the concept of pressure and the different scales, pressure scales that are used, and also temperature and the different temperature scales that are used. Okay. One of the things we're going to look at is entropy. Very briefly, this idea of disorder of energy and how you can use it. Okay. So pressure. Pressure is just defined as a force per unit area. Now here's an example where you have a cylinder with a gas inside of it, and you're applying some force on a piston on the top of the cylinder with a certain magnitude. Now inside here, the piston actually has, if you were to take like a view from the top, this is circular, and you can think about the surface area. The surface in here is just a circular surface, which of course you can calculate is just pi r squared, the radius squared, and then you have a force. Now, for example, if the force was 10 pounds pushing down, and the cross-sectional area of this circle of the piston was 10 inches, you would just have 1 pound per square inch of pressure. And that would be the pressure of the gas everywhere inside the cylinder. Okay? So it's quite easy to figure it out. In this case, previously, in a previous chapter, we used P to represent force. In this case, P is going to represent pressure. So force over area is going to give you the pressure. Right? Now, when we talk about pressure, we need to really know what the reference point is for that pressure. And there's three different types of pressure that we'll talk about here. One is the absolute pressure. Another is gauge pressure. And the other one is the atmospheric pressure. And the different formulas that we'll use for these when we're talking about the relationship between gauge and atmospheric pressure, and gauge atmospheric pressure, and also vacuum pressure. Now, this one is like pure vacuum. Maybe you should say pure vacuum here. All the air has been evacuated. If you're actually looking for the pressure where the pressure is less than the atmospheric pressure, so you're kind of in this range here, let's say, and you wanted to find out what that vacuum pressure was, you could actually do it just by the atmospheric minus the absolute pressure to give you that value. Okay. So this just means pressures, P's pressures. Okay. This would be a common one we'll use right here. Okay. So temperature. When you think about temperature, you're really just thinking about like the motion of the molecules of the actual substance. So you can think about that as like its kinetic energy. We have different temperature scales. We have Kelvin, Rankine, Fahrenheit, Celsius. And it's really just a matter of, what they're related to or what their reference point is. And we can see that, in Celsius and what the equivalent Fahrenheit temperature is. So Celsius 0, which is basically ice point of water at 1 atmosphere, is equal to, freezing point of water essentially at this just means basically freezing point of water at sea level essentially. 0 for centigrade and 32 degrees for Fahrenheit. Okay. Now, in terms of the delta or the changes, Celsius and Kelvin are the same. They have the same change, except Kelvin now goes to absolute 0. Kelvin's the temperature relative to absolute 0, and instead of the freezing point of water at 1 atmosphere. But the deltas are the same, right? The scale or the values of the changes are the same. Right? Now we have the same analogy here with Fahrenheit and Rankine. Now the relationships between the different temperature scales, you can easily calculate them by using different forms of these three formulas, which we'll look at. Okay. All right. So that's good for now.